Hello everyone, we are back again, and this time we're getting into some even more exciting stuff than last time. So in the last video that I made, we looked at how to factor trinomials where the first coefficient wasn't 1. So in other words, instead of it just being something like x squared plus 6 plus 9, we looked at something like, well, what if it's 4x plus 16 plus 32 or something like that, right? And we discussed the fact that you could factor with the 4 and then continue on from there. Now we're going to move forward a little bit. Let me clear the board here. We're going to look at more examples if that first coefficient is not 1, but we're going to dial it back a little bit. Before we talk about factoring some more, I just want to revisit multiplying two binomials, but this time we're going to add some negative coefficients. So that's going to be our title. So multiplying binomials with negative coefficients. Right. So before, when we multiply binomials, it might just be like x plus 2 times x minus 4. Well, this time we're going to add coefficients to those variables, and we're going to throw around some negative numbers as well, because that shouldn't really make things too much more difficult, because again, the rules stay the same. The rules don't change just because the numbers of the variables do. So let's have a look at an example here. So let's say we are going to expand negative 2x plus 8 times, say, 7. I'm even going to rearrange this a little bit, minus 3x. So this looks a lot different, right, than stuff that we're used to. We've got a negative 2 in front of the x. We've got a negative 3 in front of this x. We've flipped the negative 3x and the plus 7 here. Now don't fall into the trap in thinking that you can just switch these two and then that's equal to 7 negative 3x is not the same as 3x minus 7. I've seen a lot of folks flip that. You can flip these two, but the signs have to follow them. Remember, that's actually a positive 7 there. So it is equal to negative 3x plus 7. So if you did want to flip and rearrange this around, you could do that. But that's not what we're going to do here. We're just going to keep it. So I'm going to do my best to erase this here. Hard eraser. Let's get this out of the way. And we'll go back to our original problem here. So again, we could use the same methods that we've used before to solve this. Method 1, remember from a couple videos ago, we talked about the rectangle diagram. We can use the exact same strategy here. Nothing really changes. So again, I'm going to make a nice little rectangle, and I'm going to divide this into sections based off how many terms there are. Since there's 1, 2 terms there and 1, 2 terms there, I'll divide that into 2 columns and 2 rows. And what I will do is I'll color code these. So again, I'll call this the orange side over here, and then this can be our yellow side. Our orange side will line up here. Again, it doesn't matter if you put the orange on the top and the yellow off to the side, or vice versa, but I will put the orange off to the side for now. So minus 2x plus 8, and then for our top we've got our 7, and then minus 3x. And again, if you had your minus 3x over here and your 7, at the end of the day it's not going to make a huge difference, right? But I will keep it this way just to show you that it doesn't matter if these are rearranged. Don't get hung up on that fact. Just do the rules that you know, and the math will work itself out. So going back to our rectangle diagram again, to fill in this little quadrant up here, we're going to multiply the two terms that correspond with it, right? So this would be minus 2x times 7. Well, minus 2 times 7 is minus 14, and then the x there, so it's minus 14x. If we go across to the next column, we have minus 2x times minus 3x. Well, minus times a minus is positive, so that's going to give us positive 6x squared, because x times x gets us our x squared. Again, so when you multiply your, say, your minus 2x times your minus 3x, you pretty much treat the coefficients like their own little world, and then you treat the variables like their own little world. So I treated the coefficients, I multiplied them together, that gave me my new coefficient, and then I multiplied the variable term to get us a new variable term. That's how I did that. The plus 8 times 7 gets us a positive 56, and then last but not least, our plus 8 times our negative 3, negative 3x rather, gets us negative 24x. And then same thing like we did a couple of videos ago, we're just going to add all these up. So I can say that negative 2x plus 8 times 7 take away 3x equals negative 14x plus 6x squared plus 56 minus 24. Sorry, I know I'm taking us off screen a little bit here. Minus 24x. This is messy. Let's rearrange this, and actually I'll write a little bit smaller so it fits in one line. So minus 14x, we've got two x terms, we've got an x term here, an x term here, so let's simplify those. I'm also going to rearrange the order of this and put our x squared term first. So we've got 6x squared minus 14 plus minus 24 gets us minus 38x, and then our plus 56 is left over. Looks a lot nicer than that mess. So the only thing that the 3x or the negative 3x being on this side of this binomial did was rearrange the order a little bit, but that's okay because the math still checks out and we can always rearrange it later. So that is how you use the rectangle diagram to solve this. Now the other strategy that you could use is the distributive property. And since this is a binomial times a binomial, it follows that FOIL acronym: first, outside, inside, and last. Now, so again, if I want to just rewrite this, negative 2x plus 8 times 7 minus 3x, minus 2x times 7 gets us our minus 14x, minus 2x times negative 3x gets us our plus 6x squared, 8 times 7 gets us our 56, and then 8 times negative 3x gets us our negative 24x, and then it's just a matter of rearranging, combining like terms, etc. So our 6x squared, I always like putting it in standard format with our x squared first, and then our x variable is our second term, and then the constant is our third. So that's what I'm going to do. So it's positive 6x squared, and then our negative 14x plus negative 24x gets us negative 38x, and then last but not least that constant of 56. So you can see both strategies produce the same result. And again, the rules stay the same. Even though there's a negative number in front of the x, even though there's a number at all in front of that x, even though in this second binomial we have rearranged the constant term and the term with a variable associated with it, it does not matter. I use the exact same strategy as if this was x plus 2 times x plus 3, right? We set up the rectangle diagram the same way. The only thing that changes when it came time to combine the terms, they weren't in the same spot. That's literally the only difference. So please don't let rearrangements like this throw you off too much. Anyway, that all being said, that's all I have for you today. I hope you guys are having a great time with these videos and that you're having tons and tons of fun with all of the wonderful math, and I hope they're being helpful for you. Anyway, that being said, I will upload this and get started on the next video for you guys. Hope everyone is doing well and that you're staying safe. Take care.